We're going to start at the most important part, which is the soldering iron, as this will have the largest impact on building better boards. This isn't to say you can't just use any old cheapo iron, but I would heavily recommend one with digital temperature control. It's helpful to have the ability to use different temperatures in order to prevent issues. For example, when soldering diodes, I stay around 300°C in order to limit the risk of melting the switch housing. However, when soldering the rows and columns, I sometimes can go as high as 350°C in order to get more heat into the copper. That being said, my personal iron of choice is the TS100. I got it originally for fixing my drones in the field, but quickly found out it's a great iron for everyday use too. I can power it off a battery, and it has tons of features like auto shut off and sleep mode. The tips can also be swapped, which leads me in my next tip, the tip. I use a chisel tip, which allows me to spread heat over a larger area. If you use something like a pencil tip, you'll likely have issues getting enough heat into both parts, which in turn will lead to bad connections. The iron, however, is only one half of the equation. You also need good solder. Although it might sound like a good idea for your health, lead-free solder is absolute garbage. I personally recommend 6337 leaded solder. Now I know that sounds bad, and honestly it kind of is. This stuff is 37% lead. However, if you aren't already using this solder, switching to it will lead to some massive improvements. I recommend this alloy over say 6040 as it doesn't really have an intermediate state. It goes from liquid to solid almost immediately. That being said, make sure you are in a well-ventilated area, and if you want to go overkill like me, maybe consider a respirator too. So before we go into tips on how to improve these builds, let's talk for a second about some of the components. The wire I use to connect the columns and rows is just 16 gauge bare copper wire. I first straighten this in a drill and then simply cut it to length. As for the diodes, I use ones with a model of 1N4148. I don't know exactly why this is the diode of choice for keyboards, but I think it has something to do with the fact they're super cheap. I got a bag of 500 new old stock from eBay for around $10. As for the wire that is used to connect to the controller, I just use Ethernet cable. I prefer this because for each foot of cable, you actually get 8 feet of wire, since Ethernet is comprised of 8 data lines. This wire is also really good since it's fairly flexible, making connecting everything super easy. The last thing I recommend while we're talking about components is using PCB mount switches. The little pins that normally clip into the PCB can be very helpful to hold the copper in place. However, if you are using plate mount switches, you can just use tape to temporarily hold the copper in place. Then you can kind of tack weld small portions before going in to fully secure it. Now that you know the tools and components to use, let's go over some soldering tips. The biggest thing is that solder will always flow towards heat. This means if you're having issues with, say, solder sticking to your iron, for example, it's likely the part you're trying to join simply isn't hot enough. What I like to do when soldering rows is get sufficient heat into the wire first and then begin adding solder. I can then pull it where I want it to go. If you're still having issues with solder not flowing properly, you can use flux to help it. But this shouldn't be needed if you have proper technique, and in my elitist mind, I think it's kind of cheating. Let's move on to the matrix now, where there are a few things you should know. Firstly, the diodes should be coiled before attaching them. This helps with both holding them in place before soldering, as well as improving the overall connection for the lifespan of the board. It's also important to keep in mind that you should use a lower temperature when soldering diodes in order to prevent melting the switch housing. Personally, I use 300°C, but you could go a bit hotter or colder. It's just important to not go too high. Then when soldering the diodes to the copper, I recommend wrapping them around at first, as this will give a better connection. Another thing to note in particular for the matrix is that you should use electrical tape first to insulate the intersections and then heat shrink over that. The reason being that if you skip this double step and use just heat shrink, you may encounter shorts. The copper gets hot enough to sometimes melt through a single layer, which then would cause an unintended connection between a column and row. This is something that's very hard to isolate where exactly the issue is coming from, so it's best to prevent it as much as possible from the start. After you finish wiring up the matrix, you need to obviously connect everything to the controller. When I first started hand wiring, I thought that these connections could only be made by connecting the ends of each column or row. However, I found out that you can actually connect any part of the copper to the controller. It really doesn't matter and makes no real noticeable difference on latency if that's a concern to you. Also, what I like to do now is just like the diodes. I wrap the wire around the copper first before soldering it in place to secure it better. The other thing when it comes to connecting the controller that may seem like a no-brainer is pre-tinning the pads and wires. I've often skipped this step and it just makes life so much more difficult. By pre-tinning, you basically just have to touch the two parts and they connect. The final tip I want to share has to do with stabilized keys, as these are often a common pain point, at least for me. The problem with 3D printed plates is that often the tolerances can be a little off. This isn't an issue for 1U keys, however keys that use stabilizers can cause issues, especially if they're longer than 2U. Often they will bind and just not function properly, but this is a pretty easy thing to fix most of the time. All I simply do is use a heavier switch or spring for these keys and the problem is solved. This isn't an optimal solution honestly, but it beats having to redesign and reprint the plate multiple times to try working around the tolerances. It also isn't normally a big deal anyway, since stabilized keys are typically something like a spacebar. So those are some of the tips I wanted to share that I noticed had the most impact on making my hand-wired boards a lot better. Like anything, don't just take what I say say as the only way to do something. There are almost certainly better ways for all of this. I just hope to guide you in a direction that gets you there. Having said that, if you did get some use out of this video, how about giving it a like and maybe subscribing too? It really does help the channel grow so more people can get use out of these videos. Also, just like usual, if you have any questions, feel free to ask. Anyway, I'll see you next time.